it's lesson 20, and in this lesson we're going to have equations with variables on both sides. So this is where it gets interesting, and this might also be the place where your work might start to look a little different than your peers, but you may end up with the same solution anyway, as long as you're accurately combining like terms and using inverse operations. So here's what we're looking for. We're looking to see that you can distribute properly if there is an opportunity for that, and that you're combining your like terms accurately, that you're using your inverse operations, and then you're using your inverse operations to isolate the variables. So we're using inverse operations to put constants next to each other and variables next to each other. We want them on the same side, variables together, constants on the other expression, and then we're going to isolate those variables. So let's jump in and see what this looks like. All right, with this first problem, I'm going to start by combining like terms because I see like terms. So here I have 10n is equal to -2. Now I can simplify this. It's a one-step equation. I can isolate the n by dividing by 10. N is equal to -5. And as always, you can go back into your work and actually double check that. So I'm not going to show it now just because of space, but you can go back in and do 8 times -5 and 2 times -5. Is that equal to -2? All right, let's go to the next one. And here I'm looking at each expression, and both expressions are simplified. I have 8n minus 7 and I have 2n plus 5. So now what you want to do is you want all your variables on the same side, and you can make decisions here. I'm going to separate this kind of like a which one would you do. And let's say you decide that you wanted all your variables over here on this side. Let's say you want the variables here. So I'm going to subtract 2n here, and I'm going to subtract 2n on the other side. Okay, this way I have no variables on the right, but I have 6n minus 7 on the other side. Right now I want all the constants on the right side, so I'm going to add 7 to both sides, and now I have 6n is equal to 12. I can divide by 6, and my final answer, n, is equal to 2. I'm going to box it so you can see it. All right, but let's say you went and you moved it the other way. Like, remember I said you and your partner might have different answers. So let's say your partner decides, I want all my variables on this side. Okay, that means you're going to eliminate 8n from the other side. I'm going to add its opposite, and that leaves me with 7. -7 is equal to -6n plus 5. And now I'm still going to be rid of the positive 5's. So now I have -12 is equal to -6n. And I'm going to divide by -6 on both sides. And lo and behold, you still end up with n is equal to 2. So I'm just doing that to demonstrate that it didn't matter. As long as I have all the variables on the same side, and all the constants on the other side, on the other expression, you should get the same solution. As long as you're using the correct inverse operations, you should come up with the same answer at the end. All right, so just looking, what was the difference between our first equation and the second one, our second example? The first one had all variables were already on the left expression. This was in number 1, our first example. In number 2, we had to move a term with variables. And that was the big difference. So We want to make sure they're already on one side. In our first example, it was already true. All our ends were already on one side. In our second example, we had them on both sides. So we had to decide, am I moving 2n here or am I moving 8n there? All right, so hit pause and jot this down into your notes. Okay, we have a Regents question here. We have some complicated math, so we're going to do it piece by piece. To start off, I already see I have an x on both sides, so I'm going to have to move that at the end. And I also see that I have to distribute. So let's start off with that. We're going to distribute the negative 2/3, so 6 minus 2/3 x plus, I'm going to put a 1 under the 5 so you can see it. This is actually going to be negative negative 10/3 is equal to 4x. All right, let's combine some like terms here. And you could already see we have some fraction action work going on. So I need to combine these parts over here. 6 plus 10/3, okay? Just for convention, just so you can see it, I am going to turn this to 3 1/3, just so you can actually see why I'm getting 9 1/3, right? Minus 2/3 x is equal to 4x. Okay? Now, so far, looks pretty good, but I have x's on both expressions, so you got to make a choice. Do I want to move this 4x over and end up with a 0 here, or do I want to move the 2/3 over? And that's actually what I'm going to want to do. So I'm going to make myself a little space so you can follow along. So 9 1/3 minus 2/3 x is equal to 4x. I'm going to add 2/3 x. And that leaves me 9 1/3 is equal to 4 2/3 x. All right, so far this is better. I still need to separate that coefficient from the x, so I need to divide by 4 2/3 on both expressions. So here on this side, I'm going to be left with x. So let's do that second part of math so you can follow along. So I have 9 1/3 divided by 4 2/3, and it's just middle school math. It's meant to look intimidating. It's okay. I'm going to change these to improper fractions. And then I'm going to multiply by the reciprocal. All right, and just looking at this part, I noticed that I have a 1. I have a common factor. Just remember when we did this with when we were doing dimensional analysis, I have a 3 and a 3 here. So they are going to cancel out. It's still going to be 3 divided by 3, which gives us 1. And now that leaves us with 28 over 14, which simplifies to 2. So x is equal to 2. And that's our final answer. This one was a little bit more complicated. It was a long Regents problem. What made it tricky was the fact that it had fractions, and I chose to walk through the actual fractions with you rather than just use my calculator. I also chose not to change this into decimals because these were non-terminating decimals. That's it for today. Look to see I did distribute, I did combine my like terms, I did use my inverse operations, and I did isolate my variable. Make sure you're demonstrating all of this in your work as well, and if you're struggling with any area, get feedback from another person. Put a partner in the room, check off that you're able to do those steps in your work. Would a teacher also see that you can do those steps? If not, get feedback on how to actually work through those parts of the problem. That's it for today. I'll see you in the next one. Be well.